Welcome to Q&A Wire.
Okay, so we're doing chapter 18, problem 43. So this is a long one here, just warning you now. So part A is asking us, from the van der Waals equation, show that the critical temperature and pressure are given by this. So it also tells us a hint here that use the fact that P versus V, the P versus V curve has a critical point, or has an inflection point at the critical point, so that the first and second derivatives are 0. That's what we want. Has inflection point. Okay, so that means how we're going to solve this is we're going to take our van der Waals equation. So this is P, and it depends on V and T. So we want to set dP dV equaling 0 and dP or d2 equaling to 0, the second derivative with respect to V. Awesome. So this is all at a constant t, so I probably shouldn't write that here. So we just assume it's a function of v. So first here, let's write down what this is. This is RT over v over n minus b minus a over v over n squared. Okay, so now let's start taking derivatives. So dp dv. So if we just differentiate the first part with respect to v, we should be left with negative nRT over v minus nb squared. Awesome. And the second equation, or second term in this differentiating, should give us 2an squared over v cubed. Awesome. So this is the first equation. We want to set this equal to 0. Before we move on, let's go ahead and find the second derivative. And this is easier since we can just take the first derivative of that one. So this comes out to being 2nRT over v minus nb all cubed. And the second term is minus 6a n squared over v to the fourth. And we want this also equaling 0. And these both equaling 0 at the critical temperature here. So let's now simplify both of these and solve for the critical temperature. So if we move these over, we can set 2a. I'm going to block these off so I don't lose track of where I am here. Let's erase this. Okay. So we have 2an cubed over v cubed, and this should equal T critical over v minus nb squared, or T critical equals 2a n cubed over v cubed, and this is times v minus nb squared over nr. So these n's will cancel, and we're left with T critical equaling 2a n v critical minus nb squared all over r v critical cubed. Cool. So now we can also simplify the second derivative that we set equal to 0 for t critical. And this we have 6a n squared over v to the 4 equaling 2nr t critical over v minus nb cubed. And this corresponds to a t critical equaling 3an v critical minus nb cubed all over r v critical to the fourth. So these are looking pretty similar. So now we have expressions for what t critical are, so we can set them equal to each other. And that lets us cancel these guys, this So we're left with 2 equaling 3v critical minus nb all over v critical, or v critical equaling 3nb. Cool. So if v critical equals 3nb, we can now just work our way back and figure out what t critical is. So t critical now is 2an 3nb minus nb squared all over all over r times 3nb cubed. So let's plug that in. So this becomes 2an times 2nb cubed all over r times 9n cubed b cubed. That simplifies to 8a over 27 b r. Yep, so we have n here, 2 n's there, the n's cancel out. Awesome. So this is t critical now. So this equals t critical. So if we have v critical and t critical, let's use our equation here to solve for the critical pressure. So this is nRT critical over v critical minus nv. So this easily we can solve for is, oh, sorry, that's just the first part, right? We had to add in the second part of the equation. Okay, so let's start plugging in nr, and now t critical is 8a over 27b r, and then we have 3nb minus nb, which is 2nb, minus an squared over 3nb squared. If we simplify all this out, it comes out to being a over 27b squared. And this equals p critical. Awesome. So that's part A. We have p critical and t critical, and these are both exactly what we were trying to show. So awesome, that worked out perfect. Let's move on to part B now. So part B says determine A and B for CO2 with a T critical of 304 Kelvin and P critical 72.8 atmospheres. Okay, so to evaluate the constants, we just need to figure out a couple different ratios. So first, we know that T squared over T critical squared over P critical, and this equals, plug in what we found out before, 8a over 27br squared all over a over 27b squared. This equals 64a over 27r squared. So now we can just solve for what A is in terms of P critical and T critical. So A now is 27R squared T critical squared over 64A, just 64 B critical. So now we can just plug in all of our values here. And this becomes 27 times 8.314 squared, 304 squared over 64 times 72.8 atmospheres is the same as 1.013 times 10 to the 5th pascals. Cool. So 1.013 times 10 to the 5th pascals. And plugging all that in, we finally get an A equaling 0.365. Awesome. So this other ratio here, we can now do T critical over P critical, and this is 8A squared over 27 squared. Sorry, doing too much in my head here. 8A over 27BR over A over 27B squared. So we can see the A's cancel, 27's cancel, and one of the B's cancel, and we're left with this being 8B over R, or B equaling RT critical over 8P critical. So this one's a lot easier to calculate here. This is just 8.314 times 304 over 8 times 1.013 times 10 to the 5 pascals. So this comes out to being a B equaling 4.28 times 10 to the negative 5. And these all have the same units as A and B normally does. I'll write that out just so this is in meters to the 4 over mole squared, and this is meters cubed over mole. Awesome. That should be the whole problem. We finally got